So it's a jam-packed evening, lots of fun, lots of running around for you. And as I said before, we should get started. I'm going to introduce Laszlo Varro, who's going to start off with our math presentation. I think he deserves a clap.
I have exactly 12.5 minutes, so hopefully you forgive me for not spending much time on formal introduction. There's some more important issues to share with you. We'll be following a number line tonight, and I understand this is not the most exciting context, but it is useful to deliver the message that I would like to share with you. Number lines in general are used to represent something, an extension from small to big. But of course, if you think about this, we use number lines in all walks of life, size, price, whatever examples I brought up for you. And of course, we can see where CIS mathematics fits on the quality line. Now, of course, I kind of understand your point. Some of you will put us somewhere on the positive side, others will put us on a more negative, and then I know there are some of you who will put us off the scale on the other end. So, well, I tried to address your concerns today, and of course you can always come back with questions. This is a comment I received last year towards the end of the school year from a year 8 parent. Well, not much to say about it, perhaps the parent was right, we'll see. Timeline, old and new, and of course in our case, students enter somewhere and they leave somewhere. We have certain educational goals. Where they come in is quite simple. In this case it's year 7 because this is the year 8 through 13 open house, so we won't spend much time on the year 7 program, but we look at the year 8 and on. And of course where they go, well, we'll talk about that more later. And in between we have certain stages, certain very important stages that we need to look at. But let's see, where do we want to take your children? I think that is the most important question. What kind of students do we want to see at the end of year 13 in mathematics and in general? Well, first of all, most of these goals are already clearly set. Perhaps the most important of those is the mission statement. I suspect you are familiar with the mission statement. If not, I strongly urge you to read it. It talks about academic excellence, inspire lifelong learning, dual language enrichment, respectful citizens, the usual thing. Those are further divided into objectives. These are currently being revised, and based on those objectives, we have our subject-specific expectations. And of course, there are other issues. One example for you there is the IB Learner Profile, which you can't yet access on Moongate, but I suspect in the near future you will have access to it. We have various policies. So there is a clear set of guidelines that we need to follow. On the other hand, I happen to be a parent myself. I have 2 boys, one in year 12, one in year 13, and the year 13 boy is considering his college options. So I happen to know that all these goals can be turned into 2 very simple expectations. A good college and making your kids little Einsteins. Well, let's see what we can do about this, and what actually we do about this. Well, let's look at the universities first. Again, as a parent whose son is looking for a good university, I've been reading university brochures, and pretty much they are all the same. The quotes I'm bringing up for you are from New York University. They talk about independent judgment. I won't read it out, but you see the big picture. There is nothing here that do well on an exam. Very important, right? These are the general expectations. And these are very similar to what we do, what we say in our mission statement. Of course, I'm here in my role as a mathematics teacher, so perhaps these should be translated into mathematical expectations. And there is no better source to go to than Cambridge University Mathematics Department. This is what they say in their brochure. Once again, if you don't want to read the whole thing, perhaps you just look at the red highlighted items. Communicate, consider, understand, analyze, reflect. These are all more serious thinking skills than be able to solve a quadratic equation. And we have to take all these into consideration when we design and decide what we do in our mathematics classrooms. So let's see. Back to the timeline. I suspect you're all aware of the fact that in year 7 through 11, we have the IB Middle Years program. This is what I'm representing with this yellow field. In mathematics, we have to develop a clearly defined set of skills, and these skills, once again, are very similar to what we require in our mission statement and what universities expect us to do. Investigate, communicate, reflect. These are very well, clearly described and explained in relevant documentations, each of which you can access through Moongate. And once again, I strongly urge you to read those. And of course, there is the old, well-known hardcore mathematics, which I can just translate as know your stuff. Be able to solve questions. There is a slight problem, though, which I definitely have to mention, because this is always a source of displeasure, parental displeasure. These are the grades or attainment levels or scores that we can assign to represent different achievement levels. If you look at it, you see that knowing traditional old school mathematics receives a credit of 8, doesn't matter what we call them, and all the others are almost carry the same weight. Problems. Let's look at an imaginary situation and analyze who gets a 6 in our subject. Student A, student B. If you look at the achievement levels in different criteria, you see that they pretty much perform almost the same altogether, 21 and 22. I would like to highlight the fact, though, that student A can solve mathematics problems, while student B can't. What student B can do is can very well reflect on his or her errors, can communicate her ideas very well, yet I still wouldn't say that he or she is a good mathematics student. Now, he is a good student, and there's absolutely no problem with this. After all, we need lawyers, right? But if I'm looking for a mathematics candidate for the future, this is a better student. Now, of course, this is when you pick up the phone or send me an email that, what are you guys doing there? My kid can answer every single question. Half of his classmates go to him to ask him how to solve the problems. How come my son or daughter gets a 5? Sorry, that's a 5. And how come the other kid gets a 6? Well, this is how. All right? So please make sure that you and your children are aware of it. We constantly tell them, obviously, that these are not skills that they can just ignore. Usually these problems are faced by students who join us from other schools in year 7, year 8, Singapore International School and ESF schools. Serious problem, we are working on it, but it comes up all the time. Let's move on. The other issue, we have mixed ability classes in year 7, 8, and 9. Now what does it mean? Plainly and simply, it means that we do not group students according to their abilities. Here I could simply hide behind CIS policies. CIS policies are that we have mixed ability classes. Or I could just say that this is what NYT wants. But actually this is also what I want. I firmly believe that dividing students into different ability groups at this stage is actually cruel.